Welcome to today's webinar. Topic today is most frequently asked questions answered by Dlubal support team. Our regularly webinar that Markus Baumgarte and I present every 4 or 5 weeks. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software, for instance, the Dlubal website, German and English webinars, newsletters, and so on. I will be the presenter today.
Yeah, hello, my name is Markus Baumgarte. I am responsible for customer support and frequently asked questions on our website. And today I will help Andreas to answer your questions during this webinar.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. For the attendees who participate the first time in the Dlubal webinar, you can show or hide the control panel on the right side of your screen. And if you show it, you can enter a question here and Markus will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then we start with the first model and the first question. The first question is, I have created some cross sections in our section. Why is a message shown telling me that the cross sections are invalid when running the design in RSTAB and RFEM? Now you can see I run the design, the steel design, and got an error message for the design is not possible to do due to invalid section shape for design. Let's double click on the beam and you can see the cross section here. That's the R section cross section. I go in R section that you can see the cross section. Yeah, that's an U with a plate on the right side. And I created that cross section in R section and imported it into RFEM 6. But I don't define any elements. But elements, currently it's absolutely required that elements must be available to classify a cross section or parts of a cross section. Yeah, and when you import, for example, cross section from the library, the elements are automatically there usually. But for such a self-created cross section, you have to define the elements. How to do that? On the top, you can see in the menu, new element. I use a single element. And then I define the first element here with a thickness of 3 millimeters. Okay. Then the next one. That's the web. And that's 4 millimeters thick. Okay. Then 3 millimeters. Okay. So, and the last one, 3 millimeters. Okay. No, that was wrong. That is 4 millimeters. We can delete it. That's no problem. Okay. And again, the element 4 millimeters. So, okay, that's all. Then I can calculate the cross section again that we can see all is fine. All is fine. And I say file save as. Okay. Cross section with elements this time. I overwrite the old one. So, okay. And then I can go to RFEM 6, double click on the beam, for example, go to section, and I edit the section. So I go to the library here at the top. Okay, and I select from R section. And I choose the cross section with elements this time. Okay. Okay. And now the design should be possible. Yeah, those elements are necessary for the classification of the cross sections. You can see, for example, when you go to the section proof, and you can see the section classification here. Yeah, all formulas from the standard and so on. So I turn to the next model and the next question. The next question is, why is my cross-section non-designable? Now you can see the error message from the steel design add-on. Maximum allowable thickness of material exceeded. So we can double click on the member and go to the section. And I can, let me introduce the cross section. You can see it's a fictive cross section with a very thick upper flange. He's 45 millimeters thick. And when I go to the material, you can see there are only values until a thickness of 40 millimeters available. Yeah, and how can you correct that? There are two possibilities. The first possibility is to go to the main tab and check here, user-defined material, and then you can enter the values here, the values for the maximum thickness and the yield strength. But the better option is to use a new, or to modify the material, or I create a new material, European Union, carbon steel, and I know in this code the S235 GR has more values. Now you can see the different thicknesses, 40 millimeters, then 100 as maximum thickness, and you can see the decreased yield strength. Okay, I select this material. Okay, and then the calculation or the design should be run. Okay, now it's okay. We corrected this. Yeah, it happens often that the users choose not wrong material, but a material that's not valid for thicker flanges or thicker members or parts of members. Okay, then we turn to the next model and the next question. Yeah, a simple slab. And the question is it possible to calculate the spring of a column for a nodal support by the program without modeling the column? Now, if we show the results, you can see through the RFEM calculation there are singularities. We have got, for example, columns under the slab, and we defined only nodal support. So let me double click on the nodal support, on one nodal support to modify it. I create a new nodal support. And there are this option available, stiffness via fictitious column. And if I go to the table, this fictional column is recommended for point supports of 2D systems. Here you can determine the support spring constants. You can see them here from the parameters of the column that is not represented. So let me go through the single options. You have different options for the model support. I come back to that later. You can define a rectangular column head, circular. You can define the dimensions. I change the dimensions, and when I change the dimension, you can see the changing of the spring constants. Just take a look on them. Here. Okay. Then, for example, you can enter a different column height. Then, for example, rigid at the column base, or semi-rigid, or hinged. And you can also consider a shear stiffness of the column. Then you can choose a different cross section of the column if it is different than the column head. Here you have to define the material. And that's quite all. Okay, I would like to introduce the different model supports here. In the first model, surface within the column dimensions is extracted and gets elastic foundations. You can see that here on the right side in the preview. And the elastic foundation coefficients are determined from the geometry and material data from the column that we defined here. So the second option is the elastic model support. And in this model, a surface is extracted and supported in a point-like manner. You can see that in the preview as well. And the support is provided with translational and rotational springs, also resulting from the geometry and materials and so on. And to consider the higher bending stiffness in the column area, the surface is doubled internally. You can see at the moment only translational springs, but when you, for example, define here rigid or here rigid for the column head, semi-rigid, then you get also rotational springs. Okay, then the last option is the nodal support with adapted mesh, and this model corresponds to the elastic nodal support, with the second one. But no springs are applied to the point-like supports. You can see that here, and you can also see that there are no springs. We choose the first option, okay, and we need to calculate all again. So, and you can see there are no singularities anymore for this nodal support with the fictitious column. Okay, then we turn to the next model and the next question. So, and the next question is, when I select a certain object, why aren't the associated objects shown in the navigator views? So let's go to the navigator views here left at the bottom. You can see the navigator views. So, and if I activate a view, for example, for the surfaces, there's only one surface, and you can see the surface is displayed and selected, but no lines, no nodes, and so on. No loads and no nodes. Yeah, loads and nodes. And how can you avoid it? Here left at the bottom, there are the 9 buttons. And on the right, you can activate or deactivate the ignore related objects function. And if I deactivate it, then you can see also the lines and nodes and the load that belongs to the surface. And if the function is activated, associated nodes and lines are hidden, as you could see. Okay, those are the different options. Yeah, a quite hidden button. Okay, that should be all to this model and this question. Turn to the next question. The next question is, when designing steel structures, I get a message that bending about the z-axis is not applicable for the general method. What can I do to still perform a stability analysis? So let's do that on an example. I would like to design this member or this set of member. I select only this member and use a visibility by selected objects. So, and I would like to design this member or the set of member. I double click on the set of member. So design type, I select this design type, boundary conditions. So, and I define the nodal supports. I click on the member set. So, and the program recognize the intermediate nodes. And I would like to consider also a support in the horizontal direction through the coupling members. Okay, so you can see the supports. Okay, and we can run the steel design objects to design only this member set. This is member set 7. Okay, let's run the calculation. So, and now we will get the mentioned error message. So the message is general method according to Eurocode 3. 6.3.4 is not applicable for bending about z-axis. The reason for that warning is that the member set is designed according to the general method. However, this method is only allowed for loading applied in the load bearing plane, that is without transverse bending moments. And that's why the warning appears. There are different possibilities to avoid that. One possibility is to use the torsional warping add-on. And with this add-on, you could perform a stability design according to a second order analysis as a cross-section design. But there are also, in that case here, possibilities to avoid the using of torsional warping add-on. You can do that also with the steel design of add-on. So, and as an alternative, you can activate the transverse bending in the ultimate configuration. I open the navigator data, scroll a little bit, and then under steel design, you can see here the ultimate configuration. I double click on that. So, and if you are sure that you can ignore the M set, then you can increase that value here. That would be a possibility. So another possibility is under the stability, in the stability table, and you can check the extension methods and then the adapted method. And this enables double banding. So those are two possibilities. And another possibility is to, I go in the member editor again, and I change the design type from the general method to the equivalent member method. That's why I have to define effective lengths here. So node supports, I can read the intermediate nodes again, and then I can check the Z direction and U direction as support. So, okay. So you can see the supports. Okay. With supports here in that direction, also in the global Z direction through the columns, and in horizontal direction through the coupling members. I run the steel design again. So and now you can see all is fine. Okay. So we stay in the model, in the same model, but we turn to the last question for today. How can I create as quickly as possible a rigid connection for a ridge with an end plate using the steel joints add-on? Yeah, at first you have to activate the steel joints add-on here left at the top. And under add-ons, you have to check the steel joints add-on. And then we go to the design situations. Yeah, the steel joints add-on is automatically checked on for the design. Okay. So, and under types for steel joints, you can double click here, for example, then assign a node. Okay, that node, for example, you can also check on or select more nodes. In our case, the coupling members are not from interest. We deactivate them. I go in the members. At least one member end must be supported. And yeah, material section, we don't change that. So, and under components, we would like to create two end plates here. You can do that with the components. There are different components, and you can see the plate-to-plate component here. So we have to do some modifications, but I delete that. I would like to show you also the other possibility with the library, the component library. There are much more connections also for rigid. On the left side, you can see the rigid components with haunches and so on. for beam to continuous column and so on. Then the pinned connections, beam to beam, such components. Then the trusses, K joints, T joints, X joints, and so on, and the bracings. Now already a lot of components. So yeah, and of course we extend that library continuously. So we have got the category rigid and beam to beam, and we select plate to plate here. And if I apply the template, you can see the preview here, and we can press OK, and it overtakes that. So half angel is already OK. You can select also perpendicular. Yeah, but we use half. So the material should be the same as for the members, as 235. And as thickness, we use 50 millimeters. I increase the window a little bit. Okay. Also in that direction. Okay. So then for entering the plate parameters, you can use the offset or the dimensions and position, yeah, as you like. And now I enter my values here. 20 millimeters for the top offset. You can see all changes directly in the preview. You can also define a minus offset. For example, if you have got trapezoidal sheets at the top of the flanges, then such a connection or such an offset would be better. We don't have that in our example. So 110, 10, 10, 190, yeah, all the parameters are quite okay. Then we turn to the boards. We have to select the diameter from M12 to M36 are available. I select M16 and I select the strength grade 10.9. The spacing horizontally is already okay, but we want to have 6 boards in the sum. And I have to enter the spacings, at least the first 3 parameters, 169, 180, and the third parameter is calculated automatically. You can select the shear plane in thread or consider the shear plane in thread or in the shaft if you want. So then we have to define the welds for the flange 6 millimeters, web 3 millimeters, flange 6. And on the right side you can see which value you define. So now the lower flange, the weld of the lower flange. Okay, that's fine. We turn to the plausibility check. No errors found. So, and I can leave the dialog and we can run the steel joints calculation. To don't have to wait too long, I select only the maximum combination number 2. So, and I can run the calculation. So, and with the calculation, there will be created a submodel with surfaces and so on. And that's quite complicated. That's the reason why it takes a short time. The calculation, I can also already switch to the submodel. I saved that previously. That's the submodel. Now you can see where I don't display the results. You can see the plate here, then the balls with such spokes, that are help members. So then here you can see the weld, the surface of the weld, and then there are such rigid links. And that's the submodel that is calculated in the background. And usually you only see the results here. The calculation is finished. I can double click, for example, on that line here. You can see all the formulas, in that case for the weld. So, and you can see also where are the formulas in the code. So, and if you click on the left side here, above on the left side, results in steel joints, you can see the surface model with the results. You can deselect, for example, some parts of the results to, for example, show only the welds and the fasteners, or only the welds. Okay. And by pressing that button, the submodel, the steel joints model, will be saved. And that's the model what I showed you during the calculation. Okay. Yeah, that was all for the presentation. Before I would like to show you where you can find the recording and the models, I go back in the PowerPoint. If you want to book your free online appointment, for example, a free product demonstration, for example, for steel joints or steel design, timber design, and so on, just book your free online appointment. Or if you want to get not non-binding offer, then contact our sales team by clicking that link here, or you can also scan the QR code. Okay, I turn to our website. Sorry. And under dlubal.com and news and events, you can find our webinars. So that's the webinar of the next week. We would like to introduce the pushover analysis add-on. Then the week after next week, the topic of the webinar is 3D modeling for geotechnical analysis in RFEM 6. Then on the 29th June, new features in steel joints add-on. That's today's webinar. Okay, you will find the recording here, and the PowerPoint slides already here, and also the models. Okay, sorry, I was wrong. So that was all for today's webinar. Maybe a last hint: when you leave the webinar, there is a small survey. It takes you only 1 minute, I think. You can score the webinar. Would be very nice if you can do that. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars and so on, but you can leave that field also empty. Just enter any sign. in the dialogue there. Okay, thank you for your attention. Thanks to Markus Baumgartel for answering your questions. I wish all a nice weekend, nice rest of the day. Maybe we meet each other in a future webinar. Bye-bye.